Hello, everyone. Welcome to our YouTube tutorial on one of the most fundamental principles in physics and Newton's third law of motion. In this video, we will explore this law, understand its significance, and see practical examples that illustrate how it affects the motion of objects around us. So, let's dive into the world of forces and reactions. Before we begin, let me show the answers of the numerical practice I gave you in my previous video on Newton's second law of motion. Here are the answers. Comment below how many of correct solutions you got. Newton's third law states, for every action, there is an equal and opposite reaction. The action mean initial force applied by the first body on second body. The reaction mean the force applied by the second body in response to the force of first body. Remember, the action force direction is always opposite to reaction force direction. If we assume F1 is action force and F2 is reaction force, they will be equal to each other but opposite in direction. In a nutshell, they are balanced pair of forces. Let's understand Newton's third law of motion with various examples. A rubber ball rebound after hitting a hard surface. When a ball hits a ground, it exerts force which is called action, and the ground being solid exerts the same force but in opposite direction called reaction of the ground. Because of this, ball rebound after hitting the ground, it is difficult to walk on sandy soil or marshy soil. The sandy or marshy soil is very thick, so when we walk through the soil which is action force, we get a reaction force equivalent to it, makes it harder to walk through it. A swimmer moves his hands backward while swimming in water. As water is dense to swim through, the backward hand movement, which is action force, gets a reaction force in the forward direction. This forward reaction force helps swimmer to swim forward. A boatman ties a boat to some pillar on land before allowing the passenger to disembark. Passenger when get down exert action force, which in return exert reaction force in opposite direction. Due to this, boat tend to move opposite to passenger direction. The rope prevent boat from moving away from port. The birds flap their wings downward while taking a flight. The flapping of wings exerts action force in downward direction, and experience reaction force in return, which help them to take off. This is same as in aeroplanes and helicopters. Can you explain how aeroplane take off? We feel hurt in our hand while hammering a nail in wooden plank. When we strike nail with a hammer, it exerts action force. The reaction force exerted by nail and plank in opposite direction, which is our hands, is experienced and felt hurt after some time. Can you explain why we feel tired after standing for a long time? Let's do some practice. Here is a question for you. If the astronaut in the video wanted to move upward, in which direction should he throw the object? Pause this video, discuss with your teacher and pick the correct answer. The answer is C. He should throw the object downward because according to Newton's third law, the object will then exert a force on him in the opposite direction, that is upward. An accelerating equipment cart. A physics teacher pushes a cart of demonstration equipment to a classroom, as in figure. Her mass is 65 kilograms. The cart's mass is 12 kilograms, and the equipment's mass is 7 kilograms. To push the cart forward, the teacher's foot applies a force of 150 N in the opposite direction, backward, on the floor. Calculate the acceleration produced by the teacher. The force of friction, which opposes the motion, is 24.0 N. Because they accelerate together, we define the system to be the teacher, the cart and the equipment. The teacher pushes backward with a force F of 150 N. According to Newton's third law, the floor exerts a forward force F of 150 N on the system. Because all motion is horizontal, we can assume that no net force acts in the vertical direction. The net external force on the system is the sum of the external forces. The force of the floor acting on the teacher, cart, and equipment, in the horizontal direction, and the force of friction, because friction acts in the opposite direction, we assign it a negative value. Thus, for the net force, we obtain 126 N. The mass of the system is the sum of the mass of the teacher, cart, and equipment, which is 84 kg. Insert these values of net force and meter into Newton's second law to obtain the acceleration of the system, and it is calculated as 1.5 meter per second square. By grasping Newton's third law, we gain a deeper understanding of the forces that govern our daily experiences. Thank you for watching our tutorial. If you found this information helpful, don't forget to like, share, and subscribe to our channel for more exciting physics content. Keep exploring the wonders of science, and stay curious.